Point of inflection. We are given three graphs here. The pink graph, which is the first one here, we have seen it's kind of a curve here. The second diagram also have a curve, while the third one also have a curve, but the three are slightly different from each other. So actually the point of inflection is the point of change. So we have seen my curve was firstly going like this, and at this point it's gonna change. If I draw a tangent, it will be like this at this point. And in the second diagram, my tangent will be like here. In the third one, it will be like here. So these three are actually my tangent points. And I can say that the graph crossing its tangent line at a point of inflection. So the point at which my tangent line is touching the point is called the inflection point. So whenever my graph is going up, down somewhere, might possible my graph is like this. It's concave up here and concave down here. At which point it's gonna change, it changes at this point. So this is my point of inflection. Now in order to understand it in an equation form, let's do an example of that one. We have a question given here and we have to find point of inflection here. In order to find point of inflection, we have to take derivative of this equation, which will be 3x squared minus 18x plus 15. I call this equation 1. Now, in order to find my point of inflection, I need my second derivative as well. Second derivative is very connected to the point of inflection. You wouldn't be able to find out point of inflection if you don't find out the second derivative. So the second derivative of this equation is 6x minus 18. Now, I label this one 2. In order to find out my point of inflection, first of all, I have to find my 2 points for x. For that, I'm setting y prime equal to 0. If you remember, for critical value, set the derivative equal to 0. So 3x squared minus 18x plus 15 is equal to 0. Now, it's up to you. Either you're going to apply the factorization if it's applicable here, or you can apply the quadratic here. So it's up to you which one you find it easy, you apply it there. And by applying my quadratic formula here, I found my two values for x, which is positive 5 and positive 1. Now, in order to find my point of inflection, what I'm going to do, I'm simply using my equation 2. So from equation 2, I have my double derivative, which is y double prime equals 6x minus 18. I'm now setting my y prime equals to 0. So it will be 6x minus 18. And if I find out my value from here, it will be 6x equals positive 18. And if x is equal to 18 over 6, that will give me 3, the value of 3. Now, if I use it further, I have to put this value of x in my main function to find out point of inflection. So my main function is this one. So f of 3 equals 3 cube minus 9 times 3 plus 15 times 3 minus 25. So 3 power 3 is 27. 9 times 3 is also 27. 15 times 3 is 45 minus 25. They both will gonna cancel out with each other. So I'm left with 45 and 25. So that will give me positive 20. So at 3, my point of inflection is 20. So these 2, 3 and 20 are my point of inflection. So that actually means that my graph is gonna turn somewhere or changes its position or changes its shape because this is the point of inflection. Hope you understand this one. Stay updated for more videos and like my videos as well as subscribe it.